my students. This is the fourth lecture for the fourth week of COVID-19 holidays. This lecture contains the Poisson probability distribution. Poisson probability distribution is very important discrete distribution. Where the binomial random variable gives the number of successes that occur in a fixed number of trials, the Poisson random variable gives the number of events that occur in a specified interval, not forever, during an interval of time, space, area or region, distance or volume. So when I say that Poisson deals with the number of events during a specified interval, we don't mean interval of time only, but also interval of space, or of distance, of volume, and so on. Examples of activities and applications to which the Poisson distribution can be used include computing the number of telephone calls received by a switchboard in a specific period of time, calculating the number of bacteria in a specified culture اللي هي مزارع البكتيريا يعني. Estimating the number of arrivals at a car wash in 1 hour, the number of arrivals at a car wash, محطة غسيل السيارات. Counting the number of repairs needed in 10 kilometers of highways between, say, Cairo and Port Said. Determining the number of defective items and the next 100 items manufactured by a specific machine. The number of defects in a 4-meter long iron rod. Okay? In contrast, the arrival of patients at a doctor's office after making appointments, and the scheduled arrival of commercial airplanes at an airport are non-random. Why? Because it's known in advance when this event will occur. It's known in advance. It's follow a schedule. Okay? So this is not random event. Okay? And the Poisson probability distribution cannot be applied to these cases. So you understand that Poisson probability distribution only applied to events which occurred randomly. Okay? In this chapter, we will discuss the Poisson experiment properties, the Poisson formula, the mean and the variance, and the standard deviation of this distribution. First, the Poisson experiment properties. To apply the Poisson probability distribution, the following three properties or conditions must be satisfied. So what are the conditions of this distribution? I mean the Poisson distribution. What are these properties or these conditions? The first condition or property is the probability of an event or occurrence is the same for all intervals of equal length or size, and it is proportional to the length or the size of the interval. Okay, so you have to know that the probability of an event is constant, okay, for an interval. So if this interval changes, you must change the number of events during the new interval. So it's proportional to the size or the length of the interval, right? The occurrence or non-occurrence in an interval is independent of the occurrence or non-occurrence in any other interval. So the events are independent. The occurrences are random. In this description of a Poisson experiment, success refers to the occurrence of the event of interest. This is like the binomial. The probability of success not means success itself, but refers to the event of interest. Okay, the probability of question or the event of interest. And the interval refers to an interval of time or a space, such as area or region, distance or volume. Okay, all these are called intervals. The Poisson probability distribution is applied to experiments with random and independent occurrences. The occurrences are random in the sense that they don't follow any pattern, and hence they are unpredictable. So you cannot predict the occurrence of any event according to Poisson distribution or according to binomial distribution, as we said before. Independence of occurrences means that one occurrence or non-occurrence of an event does not affect the successive occurrences or non-occurrences of that event. Okay, so it's independent. All events are independent. The occurrences are always related to an interval. The occurrences or the number of occurrences related to or correspond to an interval. For example, you can say that 3 cars come to the wash car every 1 hour, for example, every 1 hour. So the number of occurrences are related to or correspond to the length of an interval. Second, the Poisson probability distribution formula. In the Poisson probability distribution terms or terminologies, the average number of occurrences in an interval is denoted by lambda, Greek letter pronounced lambda. Okay? The actual number of successes or occurrences in that interval is denoted by x. Okay? So lambda is the average number of events or occurrences, and the number of successes or number of occurrences in that interval is denoted by x. Okay? So lambda is the average number, is the mean of the distribution. Okay? But x is the number of occurrences in an interval or in a specific interval. According to the Poisson probability distribution, the probability or the function of x occurrence in an interval is computed as follows. The probability or a function of x occurrence, the number of occurrence equal x. So f of x or p of x, the probability of x equal lambda power x e power minus lambda divided by x factorial. Again, lambda is the mean of Poisson distribution. Power x, the number of occurrences in the interval, in the specified interval. E is the base of the natural algorithm. E is the base of the natural algorithm. And you can get E from or using your calculator or using MATLAB program or any other method. Divided x factorial. X factorial, you can get it using your calculator also or MATLAB program. Px as a whole can be calculated by a MATLAB function, POWERS PDF, as we will see later. So lambda is the mean number of occurrences in an interval. The mean number. Lambda is the mean of the Poisson distribution, and it's called the parameter of the Poisson probability distribution. So this distribution, I mean Poisson probability, has only one parameter. This parameter is called lambda. Okay? As we see before, the binomial has two parameters, n and p. P is the probability of success. Okay? But n is the number of trials of the statistical experiment. Okay? Here, the Poisson distribution has only one parameter, lambda. E is the base of the natural logarithm and approximately equal 2.71828. Okay? So if you want to calculate E from your calculator, write E power 1 and see that E power 1 means E equal to 0.71828. The function POWERS PDF, Poisson probability density function, with syntax y equal POWERS PDF x and lambda, Description y equal POWERS PDF x and lambda computes the Poisson PDF at each of the value in x if x equal more than one value, using mean parameters in lambda if there are many lambda or many elements in lambda. Okay, this is in case of a lot of distribution, not one distribution. X and the lambda can be vectors, matrices, or multi-dimensional array. We will not use matrices or multi-dimensional array, but you have to know that you can use them. That will have the same size, If vectors, so the number of elements in a vectors are equals, okay, and the size of matrices are also equal if you use vectors or matrices. A scalar input is expanded to a constant array with the same dimension as the other input. The parameters in lambda must be positive. Okay, so if we have a lot of distributions, the parameters, I mean the lambda, all lambda must be positive. Example 1. On average, a household receives 5 phone calls per day. 5 phone calls per day. Here, the interval is 1 day. And the number of occurrences is 5 phone calls. Okay? So this is the average per day. We have 5 calls per 1 day. Using Poisson distribution, compute the probability that a randomly selected household receives exactly 6 phone calls next day. Okay? So here, lambda equal 5 per day and x equal 6. Okay, so we have to calculate the probability of 6 calls instead of 5 calls. Solution by hand. Lambda equal 5 calls per day, x equal 6. Okay, p of x means p of 6 equal lambda power x 5 power 6 multiplied by e to the power minus lambda, e to the power minus 5 divided x factorial means divided 6 factorial. Okay, so 5 power 6 equal 15,625 multiplied by e power minus 5, which equal 0.00674 divided by 6 factorial, which equal 720. This probability equal 0.1462. By MATLAB, we will use the function Bowers PDF. Okay, so P of 6 equal Bowers PDF x and the lambda, where x equal 6 and the lambda equal 5. So the probability is 0.1462, the same as the calculated by hand. Bowers CDF, Bowers cumulative distribution function. Bowers cumulative distribution function. الدالة التراكمية. syntax P equal power CDF X and lambda. So X here means beginning with 0 TX, beginning all probabilities or accumulated probabilities from 0 to X, okay, and the lambda. Or B equal power CDF X lambda and the upper here means the complement to probability, the complement probability after X, okay, after X, okay. So if CDF equals the summation of all probabilities beginning with 0 to X, then adding upper here means the complement probability to get the summation of all probabilities equal 1, okay. So the word upper means all probabilities not included in CDF, not included in CDF, okay. So it's called the complement probability. Description: power CDF X and the lambda returns the power shown CDF at each value in X if X equal more than one value, using the corresponding mean parameters in lambda if lambda equal more than one value. X and the lambda can be vectors, matrices, or multi-dimensional arrays that have the same size, okay. Scalar input is expanded to a constant array with the same dimension as the other input. We don't need this because we will deal with only one distribution, not a lot of distribution at the same time. The parameters in lambda must be positive. It's all right. P equal power CDF X lambda and upper return is the complement, look at this, the complement of the boson CDF at each value in X, using an algorithm that more accurately computes the extreme upper tail probabilities, okay, all probabilities larger than X, it's called the complement probabilities. Example 2. A machine breaks down an average of 3 times per week. 3 times per week. This is the lambda or the parameter or the mean, and this is the interval. 1 week. 1 week is the interval, and 3 times the number of breakdowns, okay. Using Poisson formula, estimate the probability that during the next week this machine will have number A, exactly 2 breakdowns. Now lambda equal 3 and X equal 2. Number B, almost 1 breakdown. Almost 1 means 0 and 1. almost 1 واحد على الأكثر، عطل واحد على الأكثر. almost 1 means B0 plus B1. B0 means no breakdowns in a week, and 1 means 1 breakdown in a week, okay. So almost 1 means 0 breakdown and 1 breakdown. Solution by hand. Now lambda equals 3 breakdowns in 1 week. X equal 2. X exactly 2, okay. So P of 2 equal lambda power 2. Lambda equals 3 power 2. E to the power minus lambda divided by 2 factorial. Okay, this probability equal 0.224. It's so easy to calculate or to compute. Number B, almost 1 breakdown, means that x equal to or less than 1, equal to or less than 1. So x may be 0 or might be 1. So p of x equal to or less than 1 equal 3. 3 is the lambda to the power 0, e to the power minus 3 divided 0 factorial. You know that 0 factorial equal 1. Okay, plus 3 power 1 e power minus 3. Look, e power minus 3 is a constant here and here, and for any other probability, as lambda is fixed. Okay, so this not change, otherwise lambda change. Okay, so 3 power 0 equal 1, e power minus 3 equal 0.0498 divided by 0 factorial power equal 1. Okay, plus 3 power 1 equal 3, and the e power minus 3 is the same as this, so you can compute once, okay, and repeat, divided by 1. This also equal 0.2. Using MATLAB, we will use Bowers PDF and also Bowers CDF. Bowers PDF to compute x equal exactly 2 breakdowns. To compute almost 1. So we have x equal to lambda equals 3. P(F2) equal Bowers PDF Okay, so using MATLAB we will use Bowers PDF and the Bowers CDF. When computing B(2), we use Bowers PDF x and the lambda, where x equal 2 and the lambda equal 3. This probability equal 0.224 as we computed by hand. x2 means almost 1. x2 almost 1, 0 and 1. or from 0 to 1, or where x, if we use cumulative probability distribution, so p of 1 means utmost 1 here, equal power CDF x and the number here, x equal 1. 1 here means utmost 1. So this probability equal 0.1991. Okay, or you can use sum of Bauer's PDF, sum of Bauer PDF for x2, where x2 equals 0 and 1. So it's better to use Bauer's CDF instead of using Bauer PDF. Okay, the result is the same, but here Bauer's CDF in this case is better than Bauer's PDF, right? Example 3. A company provides free examination of its products for 10 days. If not completely satisfied, a customer can refund the product within the period of time. That period which is 10 days. According to the past experience, an average of one of each 5 products. One of each 5 products. Here the interval equal 5 products and the number equal 1. 1 each 5. 1 each 5. 1 from 5. Okay? 5 products sold are refunded. Using Poisson formula, compute the probability that exactly 3 of the 20 products sold by this company. 20, not 5. So here the interval changed from 5 to 20. Okay, so you have to adjust lambda here. Okay, the length of interval here is 5 products and the length here is 20 products. Okay, so this is multiplied, the first interval multiplied by 4 to get the second interval. Okay, it's multiplied by 4, right? So if lambda here equal 1 during the interval 5, here lambda will be 4 during the interval 20 products. Okay, so lambda here will be 4, not 1, and the length of interval here equal 20, not 5. Okay, take care about this. By this company on a given day will be refunded. Okay, so we want to compute the probabilities that exactly 3 when lambda equal 4. Okay, and the interval is 20 products, not 5 products. Okay, solution by hand. Lambda equal 20 divided 5 and multiplied by 1. So 1/5 of 20 products equal 4. So lambda equal 4. Multiply 20 by 1/5. 1/5. Okay, and x equals 3. So p of 3 equal lambda power x, lambda equal 4 here, and x equals 3, multiplied by e to the power minus 4 divided by 3 factorial. Okay, this probability equal 0.195. by MATLAB, we must adjust y to be suitable for 20 products instead of 5 products, as I said before. Then apply the suitable function as follow. Lambda here equal 4, or 20 divided by 5 and multiplied by 1. So lambda equal 4 and the x equal 3. So you have to adjust lambda first before using the Bowers PDF function. Then b of 3 equal Bowers PDF, x and the lambda. The result is 0.195 as we computed by hand. The third point here is the mean and the standard deviation, or the variance of Poisson distribution. The mean and the standard deviation, or the variance. You can get the variance first, then compute the standard deviation, which is the square root of the variance. Okay. The mean or expected value and the variance of Poisson probability distribution both are equal lambda. So here lambda is a parameter of this distribution and also equal the mean of the distribution and also equal the variance of this distribution. Okay, so here lambda is a parameter, is the mean, and also equal the variance. Don't forget that. And the standard deviation is equal to the square root of lambda. Square root of lambda. So for the Poisson probability distribution, mu or mean or expected value equal lambda, sigma square or variance equal lambda also, and sigma or standard deviation equal the square root of lambda. Using MATLAB program, the function Bowers state provides the mean and the variance of probability distribution given y, given the parameter y, lambda. Lambda looks like reciprocal y. Okay. Bowers state, Poisson mean and variance. Syntax: M equal Bowers state of lambda. Bowers state of lambda. Okay. Or M and V equal Bowers state of lambda. Description: M Bowers state lambda returns the mean of the Poisson distribution using mean parameters in lambda. Okay, the size of M is the same as of lambda. Mu or M and the V, Bowers state lambda also returns the variance V of the Poisson distribution. Okay, so you can use Bowers state to get the mean and also to get the mean and the variance at the same time. Example 4. On average, 2 new accounts are opened per day at Nasr City Al Ahli Bank branch. Using MATLAB, find the probability that on the next day the number of new accounts opened at this branch will be: number 1, exactly 6. Here look, on average 2 new accounts per day. Here the interval is 1 day. The interval is 1 day. And the lambda or the mean is 2. 2 per day. This is the lambda. So lambda equal 2 and the interval equal 1 day. Now we want to compute the probability that this branch will open exactly 6 accounts in one day or in next day. Atmos 3, so Atmos 3 means 1 2 3 or 0 1 2 3 0 1 2 3. Atmos 3. At least 7. At least 7 means 7 and more. 7, 8, 9 to infinity. Okay? What are the mean and the standard deviation of the distribution of the number of accounts opened per 3 days? So here the interval equals 3 days, not 1 day. Not 1 day. So you have to change lambda by multiplying lambda here by 3. So 2 per day equal 6 per 3 days multiplied by 3. 6 by 3 days. So lambda here equals 6, not equal 1. Solution. Lambda firstly equals 2 for number A and B and C, but lambda for D equals 6. 2 multiplied by 3 equals 6. Okay? Using MATLAB, the first probability P of A equal BAWAS PDF x1 and lambda. x1 equals 6. x1 equals 6. Okay? So this is the first probability. The second probability of B, BAWAS CDF x2 Atmos 3. x2 equal Atmos 3. Okay, so here x2 equals 3. It means Atmos 3, 0 1 2 3. Okay, because we use CDF instead of PDF. Okay, this is the second probability. The third probability x3 equals 6. x3 equals 6, but here we need to know 7 at least. 7 at least means 1 minus Atmos from 0 to 6, or you can use the upper as we see later. So probability of C equal 1 minus the complement probability 1 minus BAWAS CDF. Here x equals 3, so from 0 to 6, from 0 to 6, okay, and 1 minus BAWAS CDF means from 7 to infinity, from 7 to infinity, or at least 7. At least 7 equal 1 minus Atmos 6. Atmos what? 6. Okay, so this equal 0.0045. Number D, the average or the mean and the variance given by BAWAS state lambda. Which lambda? Lambda 2, the adjusted lambda, which equal 6. Lambda 2 equals 6. 3 multiplied by 2. Okay? So BAWAS state, mu and the var, mu, the mean or the average equals 6, and the variance also equals 6. So the standard deviation denoted by S equal SQRT, the square root, the function of square root of var. Var means variance. So the square root or the standard deviation equal 2.4. 2.4. Okay, so you can say also instead of for probability C, instead of 1 minus power CDF, you can use upper, okay, instead of 1 minus. Upper means the complement probability, upper. Power CDF for 6, x equals 6 and the number equal 2, number equal 2. By this way the result is the same as this one. Okay, so using upper here instead of 1 minus power CDF. Okay, so you can use this one or this one. Thanks so much, and I will cancel the hypergeometric distribution. Okay, cancel it to facilitate the mission for you, and next lecture we will explain the continuous probability distribution. Thank you and see you later inshallah. يدور النور يا أولاد.